Hello viewers, welcome to my channel. Now in this video, we want to look at this surd expression. Okay, we want to rationalize the denominator of that expression over there. Well, when we say rationalize something, that means that thing was not rational enough. Okay, so you have to rationalize it to make it more rational, or it wasn't even rational at all, so you have to make it rational. When we're saying something should be rational, a number in this case, well, we have some sets of numbers, standard sort of set of numbers. We have the set of whole numbers, which we can call the integers. We have the set of fractions together with whole numbers, which we can call rational numbers. And then the set of irrational numbers as well. Okay, so much of the story. Now here we want to make the denominator to be rational. That is, we want to make it to either be a fraction or just to be a simple whole number, right? Okay, so we do not want it to contain radicals. That is square root of non-perfect squares. Like square root of 5 is irrational, so we need to make it rational, right? So we need to do that in the denominator only. We do not care if it appears in the numerator. We only care about the denominator. So the way to go about this is to go ahead and multiply this fraction by 1. Let me put down the fraction for you. So we have, this is the solution, so I didn't write it down. 3 plus square root of 5. Okay, so like I said, we need to multiply this by 1. By multiplying it by 1, the kind of 1 I'm going to multiply is going to be such that when we take everything, we are going to get the denominator to be a rational number and no more an irrational number. So what I would do here is to multiply top and bottom by the conjugate of the bottom. Now, when we talk about the conjugate, the only thing that we care about here is this sign over here, the addition sign. Well, we know that this is square root of 3 and this is square root of 5. So, maybe not actually a conjugate, but I'm just going to multiply such that I change this sign here from addition to subtraction. The reason why I'm going to do that is because we are just having square roots here. Now, this is what I mean. When we have A plus B, okay, if you multiply this with A minus B, right, this will lead you to difference of perfect squares, difference of two squares. So you're going to have A squared minus B squared. So if this contains some square root, and you multiply it with something that contains some square root again, of the same kind, when you square it, you have just the square root to cancel, the square and the square root to cancel, okay, where this is going to be positive. And the same thing happens over here. So that is why I'm going to multiply this with a negative version of it. So let's just look at it, what I mean. So we are going to multiply the top here with this, but except for the negative, except for the positive, we are going to put negative over there. So this should be 2 root 3 minus square root of 5. Now, I said I was going to do multiplication by 1. So if I just multiply the top and leave it like that, I have changed everything in the question, which means I'm setting my own question, I'm answering for myself. So what I have to do here is to also multiply the denominator by the same thing that I multiplied in the numerator, so that they can just cancel out and we are left with 1, though we are not going to cancel it actually. So this is going to be the same thing minus square root of 5. So if you see here, we've not done anything to that original fraction. We are just writing it using lots of terms. Okay, so this and this will cancel and we're left back with what we had initially. Great. So if you multiply this at the top, in fact, this one has no effect on it because it's just multiplication. Now we look at the denominator. We need to expand this, all right? Now when we have things of this form, this and this are the same, and this are the same, different from the signs at the middle of them, just multiply the first two, square them, multiply, just take this, square it, and this and square it. So this is it. We're going to have 2 root 3 minus square root of 5. Then at the bottom, we multiply 2 with 2, you're going to have 4. Root 3 times square root of 3, you're going to have 3. You know, square root of 3 times square root of 3 will give us square root of 3 squared, which is just 3. And again, we multiply this with this, you're going to have negative square root of 5 squared, that is negative 5. So what I just did there, this times this, okay, will give us square root of 5 squared. So square root of 5 squared is going to just be 5, right? Now, I just multiply this one and this one. I multiply this one and this one. I didn't care about the others because they will be 0. In fact, try it out. Expand them. Okay, so here we see that 4 times 3, this is dot multiplication. 4 times 3 is just 12. And 12 minus 5 is 7. So we are having 7 in the denominator, which is now rational. It is no more, it's no more under the radical sign. Okay, and it is not the perfect square, but it's no more under the radical sign. So it is now a rational number. So I can put this down as 1 over 7. 7 is in the denominator. And I'll put down the numerator, 2 root 3 minus the square root of 5. And this right here ends it. So we've successfully rationalized the denominator. And that is what you get. Alright, thanks for watching.